Hello students, this video is to help with the Unit 6 review packet. This unit was all about centers of triangles, different centers including the orthocenter, incenter, the circumcenter, and also the centroid. Hopefully you tried this packet already. If you didn't already do so, pause the video, try to answer these questions, and then see if you got them right. Okay, for the first couple of questions, you needed to remember the mnemonic device, all of my children are bringing in peanut butter cookies. This mnemonic device helps you remember that altitudes and orthocenters are corresponding to each other, medians and centroids correspond to each other, AB stands for angle bisectors, and IN stands for incenters, angle bisectors and incenters, and then finally PB stands for perpendicular bisectors, and C stands for circumcenters. For the first four questions in each figure below, identify the point of concurrency, and remember point of concurrency, that means it's either going to be an orthocenter, a centroid, an incenter, or a circumcenter. For letter A, it looks like we have these given to us, these right angles, which means they're perpendicular to the bases. I also see that these lines are connected to the vertex. So since they're connected from a vertex to a base, and they're perpendicular to that base, that means that these lines are all altitudes. Since they're all altitudes, altitudes meet up at an orthocenter. Remember, all of altitudes orthocenters. For letter B, I connected a vertex to the base, but this is not perpendicular. I don't see a right angle marker here. I do see these two sides are congruent, which means this is a midpoint. If it's a midpoint, that means I'm joining a vertex with a midpoint. That indicates to me that these lines are medians. Medians meet up at a centroid, so this point is a centroid. Orthocenter, centroid. For this third one, I know that these lines are perpendicular to their bases because of these right angle markers. I also know that these meet up at midpoints of bases because they have the midpoint marks here. They don't necessarily pass through vertices. They can, but in this case they don't. This doesn't pass through a vertex, doesn't pass through this point here. This doesn't pass through this point here. So they're not going through vertexes or vertices. I know that these are perpendicular bisectors, perpendicular because of this right angle marker, and bisector because they cut the base in half. Perpendicular bisectors meet up at circumcenters. Peanut butter cookies is how you remember that. For letter D, I can see that these lines go through a vertex, here, here, and here, and they also split the angles in half. You see one arc for each of these, two arcs for each of these, and three arcs for each of these. They split the angle in half. They bisect the angle. So since it bisects the angle, these are angle bisectors. And angle bisectors meet up at an incenter. ABI are bringing in our mnemonic device. For questions 2 through 9, we're supposed to identify the point of concurrency. That's either orthocenter, centroid, incenter, or circumcenter. And all of these require you to have some knowledge of where the incenter, where the centroid, where the circumcenter, or where the centroid would be located. In order to help with that, I put together a couple of pictures that I found on the internet. In the circumcenter's case, they can be inside the triangle if it's an acute triangle. The circumcenter could also be outside the triangle if it's obtuse. And lastly, if it's a right triangle, the circumcenter is actually going to be located on one of the sides, on the hypotenuse. For medians, they're always going to intersect inside the triangle because, well, a median is going to connect a vertex with a midpoint, so it's got to go through the middle of the triangle, so to speak. So the centroid is going to always be inside, whether it's an acute, a right, or an obtuse triangle. For the orthocenter, it could be inside, outside, or on the side of the triangle, depending on the type. If it's an acute triangle, it's definitely going to be inside. If it's an obtuse triangle, that orthocenter is going to be outside. And if it is a right triangle, then it's going to pass through or intersect the vertex that is a right angle. And then unlike the circumcenter, the incenter is always going to be inside the triangle. You can remember incenter is going to be inside. Incenter for acute, incenter for obtuse, incenter for right. You could also know that because it's going to be formed from angle bisectors, and an angle bisector is always going to cut the angle in half, which means it's going to be on the interior of the angle, in other words, on the interior of the triangle. So hopefully this was helpful. If you take a look at this and try to commit this to memory, it would be very helpful in questions like this. So going back to those questions, always inside the triangle, remember inside, in center, and then centroids are formed by medians, and centroids are always going to be inside the triangle. Which point of concurrency is always on the vertex of a right triangle? We just showed that one. That was the orthocenter. Always on the midpoint of the hypotenuse in a right triangle. Well, if it's on the hypotenuse in a right triangle, that's going to be the circumcenter. That was in the pictures from before. And outside of an obtuse triangle, you should remember outside orthocenter, and outside is also going to be circumcenter, the perpendicular bisector intersection. There's a lot of vocabulary here. This is just something that you need to keep track of. Which point of concurrency is equidistant from every vertex? Equidistant from every vertex means it's the same distance away from every vertex. We're going to get to that in a second in a picture form, but just know that that is the circumcenter. And then which point of concurrency is equidistant from every side of the triangle? That's going to be incenter. Let's break into these and see what they're talking about. Equidistant from every vertex means the circumcenter is going to be the same distance away from every single vertex. In other words, if I look at this vertex and I look at this vertex and I look at this vertex, the point that is directly in between them, the same distance away from all of them, that's going to be the circumcenter. And you can see that here, the distance from here to here and the distance from here to here and the distance from here to here is the same, which means I'm able to draw a circle around the triangle, touching each vertex that has its center at the circumcenter. A circumcenter is the center of a circle that's drawn around the triangle. Which point of concurrency is the center of an inscribed circle? Well, this talks about an incenter being equidistant from every side. That means from this side, and from this side, and from this side, the point that's directly in the middle, that's called the incenter. In other words, I can draw an inscribed circle that completely circles that center and is equidistant from each side. Moving on to the next page of this packet, questions 10 through 18. If you haven't already done so, please try these questions by yourself, pause the video, and then come back to see if you got them right. More vocabulary. We're supposed to be circling the letter of the correct point of concurrency. We're looking for equidistant from the vertices. That's circumcenter. You could draw out a quick circumcenter to help you with that, or you could just memorize the facts that we told you before. It is equidistant from the three sides. If it's equidistant from sides, it's an incenter. Equidistant from vertices means circumcenter. And then for number 12, it divides each median into two sections at a 2-to-1 ratio. You could remember this by two different methods. You could remember that medians meet up at centroids, or you could recognize this 2-to-1 ratio. We're going to be looking at that a little bit later when we look at the algebra of triangle centers, but a 2-to-1 ratio is always going to be indicative of centroids. For questions 13 to 18, you were supposed to identify a segment AB. They all have an AB in them. And we're supposed to be identifying them as mid-segments, perpendicular bisectors, angled bisectors, medians, altitudes, or none of these. And we're supposed to justify our answer. So make sure when you're justifying your answer, you're giving some sort of reason as to why. In this case, the justification of this is, well, if it bisects the base, we see these two congruent segments. And if it's perpendicular to base, we see this right angle. That means it's a perpendicular bisector. Perpendicular bisector. Easy. For number 14, it intersects the midpoints of each side. I know this is a midpoint, and I know this is the midpoint because of the markings on the sides here. It splits it into two equal pieces on both sides, so it must be a mid-segment. For question 15, AB is drawn from the vertex, and it also bisects the angle. You can see these two arcs right here. If it bisects the angle, it must be an angled bisector. For question 16, it's perpendicular to the base. I can see the right angle right here. And it's drawn from a vertex. It's drawn from vertex B. So it must be an altitude. Remember, altitudes are drawn from the vertex and are perpendicular to the base opposite. For question number 17, you can see it's drawn from the vertex, but I guess that's it. It's not, there's no right angle here. It's not splitting this side into two equal sides. So that's it. So remember, one of the options was none of these. It looks like question number 17 is none of these. It doesn't fit the criteria for any of the segments that we just talked about. However, for question 18, we're drawn from a vertex. We're drawn from point B, and it also bisects that base. You can see these two lines that are indicative of a split, a perfect even split, which means it is a median. Median connects the midpoint of a base with the vertex opposite. Not too bad if you know the vocabulary, and believe me, you need to know this vocabulary. Looking at the next page, which is on triangle inequalities, hopefully you did this already. Pause the video, try these out, and then see if you got them right. All right, here we go. The first triangle inequality that you need to know is this one. It tells us that the small side plus the medium side of a triangle always has to be bigger than the largest side of the triangle. It happens with every single triangle. This is a fact of not just geometry, but reality. Small side plus medium side has to be greater than the larger side. So which of the following could represent the lengths of the sides of a triangle? All we got to do is add small plus medium and see if it's greater than large. It's not greater than here. It's not greater than here. And it's not greater than here. However, 7 plus 7 is 14, and 14 is greater than 7. Check us out. For question number 2, it talks about triangle ABC, but it doesn't give us a picture, so I went ahead and drew one. It tells us that AB and BC are 5 and 3 feet respectively. It asks for all possible values for the length of AC. And I know that AC could be, well, it could be the smallest side of the triangle, or it could be the largest side of the triangle. It could also be the medium side, but the medium side isn't going to tell us what its maximum or minimum is going to be. So we're only going to consider these two options, whether it's the small side or whether it's the largest side. If it's small plus medium is greater than large, as we said up here, that means that smallest side AC would be added to 3, and that's greater than 5, which means that AC has to be greater than 2. Instantly, we can cut off all of the other answers except for choice 2, but let's follow it through. AC could be the largest side. Small plus medium is greater than large, I should say, which means 3 plus 5 or 8 is greater than AC, which means that AC has to be smaller than 8. That fits this inequality perfectly. For question number 3, again, always draw a picture if they don't give one to you. Scalene triangle, which means all of the angles are different and all the sides are different. Angle B is equal to 45 and angle C is equal to 55. We were able to use the triangle sum theorem to figure out that last angle, that is 80. We're never going to get away from this triangle sum theorem thing. We're always going to be using the different theorems to find the missing angles of triangles. What's the order of sides and length from longest to shortest? Well, I know that the longest side is always going to be across from the largest angle. The medium side is always going to be across from the medium angle, and the shortest side of a triangle is always across from the smallest angle. So I know that this happens to be the smallest angle, 45 degrees. That means it's across from the smallest side. This one is the largest angle, 80. That's always going to be across from the longest side. I can figure it out from there. I'm looking for longest to shortest. So this one starts with AB. Well, AB is not the longest side, it's the medium side. So that means I can cross this one off. AC is not the longest side either. AC is actually the shortest side, so I can cross this one off as well. And number 2 I can cross off because AB happens to be the medium side. That doesn't mean it's going to be the shortest side from longest to shortest, so I can cross this one off too. This one is the only one that lists them from longest. This is the longest to the medium, and then AC is the shortest. I can see that AC is labeled as shortest. I went backwards with number 4, but I can still do that. PQR tells me that PQ is equal to 8. That means it's the shortest side. QR is equal to 12. That means it's the medium side. And RP is 13. That's the longest side or the largest side. Which statement about the angles of PQR must be true? Well, if this is the longest side, this is the largest angle. So angle Q is the largest. That means that angle Q has to be first in this inequality because angle Q would be greater than angle P, greater than angle R. It wouldn't make sense that angle R is the greatest one because angle R is, as a matter of fact, the smallest one. This one is possible because it has angle Q as the largest one, but it says that angle P is the smallest one. And here we have labeled angle P is actually the medium one. So that's no good. Last but not least on this page, we're told that these are medians and they intersect at a point. If medians intersect at a point, that means it's a centroid. If it's the centroid, that means it splits a side into 2-to-1 ratio. That means whatever this side is, we call it 2x, and this side we call it x, because it's a 2-to-1 ratio. I can set up an equation that says that CF, that median, is equal to CG plus GF, which are the parts of the median. Then I can say 24 is equal to CF because it's given to us, and then 2x and x, which is what we said for centroid. We do a little algebra and we find that 8 is equal to x, but we're not done because we circled what we were looking for, the length of CG. CG is 2x, which means 2 times 8, which means 16. Not bad. All right, that was the first video in our 2-part video series about the Unit 6 review packet. Hopefully you had good luck with these answers. Good luck studying.